A model suggests long-period comets may be arriving at twice the background rate. It points to a star that may have crossed the Oort Cloud millions of years ago. The star is gone. Its comet shower may not be. This is Cosmion. Point it at any question in the universe, and it will show you the answer, whether you can bear it or not. Here, a comet shower means a slow rise in long-period comet arrivals. The comets appear one by one across geological time. Tonight, their orbits lead us backwards to an ordinary star named HD 7977. The star never came near the planets. The question is whether its distant gravity reached their frozen source. If it did, some comets falling towards the Sun today began their journey millions of years ago. The Oort Cloud is a vast shell of icy bodies far beyond the planets. Sunlight is weak there, and the objects are small. We cannot photograph the whole cloud. Instead, astronomers study the long-period comets that fall out of it. Some have vast orbits suggesting a first arrival. Others have already passed the Sun and returned. Most models give the Milky Way's gravity the leading role. Its steady tide slowly changes distant comet orbits. The pull is weak, but it works for millions of years. That tide should leave a pattern in the orbital orientations of the first-time arrivals. Those orientations should favor two broad directions. But the observed first-time arrivals are spread more evenly than the tide-only model predicts. Their orbital orientations look too thoroughly mixed. The returning comets still keep more of the expected pattern. These are survivors whose paths were reshaped by earlier visits. The two groups do not match. One answer is that the Oort Cloud contains more bodies in its farthest regions than standard models predict. Another answer is that something scrambled it. That second answer has a suspect. HD 7977 is a Sun-like dwarf, with roughly the Sun's mass. Its ordinary light gives no warning of the disturbance it may have caused. Gaia measured its position, distance, and motion. It did not watch the ancient encounter. It supplied the measurements needed to rewind it. One detail made the star difficult to ignore. Across our sky, HD 7977 appears to move very little sideways. Most of its motion points along our line of sight. That geometry is exactly what a former near visitor would show today. Reconstructed backwards, some possible paths carry the star through the Oort Cloud, roughly 2.5 million years ago. The time is reasonably secure. The missed distance is not. Small disagreements in velocity preserve the age, but move the closest point enormously. One Gaia analysis gives the star about a 1 in 3 chance of passing within 10,000 astronomical units. That is deep inside conventional Oort Cloud scales, but still hundreds of times farther out than Neptune. Other reconstructions place the path closer, yet tiny changes in the star's measured motion shift the answer enormously. HD 7977 may even hide an unresolved companion. If so, Gaia's present single-star fit could bend the rewind. A companion's pull could mimic part of that tiny sideways motion. So the star data alone do not give one clean answer. The comets offer a second measurement. The new study tested HD 7977 at many possible distances. Researchers asked what passage the observed comet pattern itself would require. Most versions failed to reproduce the comets we actually see. The best matches came from simulated passages between roughly 6,000 and 10,000 astronomical units. Closer and wider encounters matched the two comet groups less well. At that distance, the star would cross the comet reservoir without entering the planetary system. Its gravity would not blast the cloud apart. It would give nearby comets small changes in speed and direction. The strongest nudges go to bodies nearest the star's path. Far from the Sun, a small change is enough. A comet can move from beyond the giant planets into the inner solar system. Some comets escape, some move onto tighter paths, others begin a long fall towards the planets. The star leaves before any of those new arrivals reach us. This does not prove the star took that route. It turns the comet population into an independent ruler. Two imperfect records can now check each other. A stellar encounter lasts briefly. Its effect on the Oort Cloud can unfold for millions of years. The cause can vanish long before the result becomes visible. Comets disturbed closer to the Sun complete their journeys first. Bodies from farther out take much longer. Their orbital clocks create a sequence, not one advancing front. In the simulations, many of the most distant arrivals reach the inner solar system, 2 to 3 million years after the flyby. That delay places their arrival in the present era. Across that simulated span, the best-fitting encounters produce 7 to 12 times more new long-period comet arrivals than the tide-only model. That is not a historical count. By the present day, the modeled rate remains roughly twice the long-term background. The peak does not arrive as one visible front. Different orbital clocks spread the response across millions of years. If the new model is right, the comet shower is not ancient history. We are living in its fading tail. This is not an impact forecast, and it identifies no Earth-bound comet. It means some comets arriving now may still carry the gravitational echo of a star that left millions of years ago. There is another way to explain the same clue. The Oort Cloud may be less concentrated near the Sun than standard models predict. With more bodies in its farthest regions, the cloud can produce the mixed first arrival pattern without a powerful recent flyby. The star-side evidence should improve soon. Gaia's fourth data release is expected to sharpen HD 7977's motion. A longer baseline can expose hidden drift or binary wobble. The Comet model makes a precise prediction. Better Gaia data should favor a passage between 6,000 and 10,000 astronomical units. That makes the idea unusually testable for deep history. If Gaia favors that range, two independent trails will meet. If it rejects the range, the stellar flyby explanation becomes weaker. Either answer tells us something real about the unseen edge of the solar system. HD 7977 is already about 250 light-years away. If the flyby happened, some disturbed comets may only now be completing their journeys. Subscribe to Cosmion. Next, we follow the new Rubin survey as it begins counting the solar system's comets.